One of the most important questions that any nerd could ask themselves is how on earth am I going to get my Tandy color computer onto the internet? I think most of us stay up at night thinking, my God, I have an Apple II, but it's not online. What do I do? So today I am pleased to be sitting next to Thomas Cherry Holmes, which is, by the way, an incredibly cool name, the lead instigator of the FujiNet project. Say hello to the entire universe, Thomas.
Hello, entire
All
universe.
right, Thomas. Give everyone the rundown on FujiNet because it is the most ridiculously cool thing in the entire universe.
FujiNet is a wireless network adapter for your favorite retro computing or retro gaming platform. Now, we started on the Atari 8-bit,
Of
but we
course,
branched off onto other.
naturally, you start on the
Yeah,
Atari 8-bit because who
yeah.
doesn't want to type on a membrane keyboard? That's
Oh,
what
God.
I
Oh, yeah.
always say.
How can you always tell an Atari 400 user? You can look at their lack of fingerprints. So.
Okay. So you started on the Atari. What? Okay. But FujiNet is a device
Yes,
and software that goes along with it.
yes.
How does it all work? What does it do?
Okay, so for each machine, we started off on the Atari 8-bit, and then we took and we branched off onto other platforms. And in each case, you have a device. In this case, the FujiNet device, it plugs into your computer. For example, on the Atari 8-bit, it plugs into the peripheral port. On the Apple II, it plugs into the floppy disk port. On the Commodore 64 and a 128, it plugs into the IEC port.
Wait, on the
And at
Apple
that
II, it plugs into the floppy disk port.
Yes, so that got one of the wonderful reactions from Woz himself, who basically said, "You guys are insane. That's probably the
Why would you
greatest
plug it? Okay,
compliment."
okay. We're gonna come back to that. We're gonna come back to that. Okay.
There was a
So
reason for it.
you plug you've got a device. You plug it in.
You plug it in.
Then what? Then what? So let's say you've
Then
got it the Atari
the
8-bit. You
first
stick
thing,
it in. What do you do?
well, yeah, the first thing that we thought that people would really want to be able to do is, of course, okay, what do you do with a device like this? Well, you can load software either from the internet or from your local SD card storage.
Yeah.
So you can take and grab software off of a server and just stream it directly onto your machine without actually needing to have it there. And then we thought, well, okay, that's great. That's useful. Let's add some more stuff to it. We added a virtual printer, which we can take and you can go into Print Shop and you can print all your favorite banners and stuff, and it will rasterize them out to PDF. So you can pick them up and print them on your modern printer.
Wait a minute. You can print. So it's a pretend printer for
Yes,
8-bit computers
yes.
so you can print
Yes, it
modernly.
simulates a whole bunch of different printers. It emulates them, and then it rasterizes them all out onto a PDF file that you can just pick them up and print them on a modern printer. Yeah,
Really? Oh,
yeah.
okay. What else? What
What
else? What
else?
else?
Okay.
What else can
So
you do
those
here?
were the
Because
two
that's
first things
crazy.
that we did. Then we thought, okay, fine. Of course, it needed to be a modem, so we went ahead and added in just a
Yeah.
basic modem that you would think of when you think of like an ESP8266 or something. It
Sure.
emulates a Hayes modem, so you can connect to bulletin boards and stuff. We also had to add for the Atari as part of the integration bits. We had to add the 850 interface
Now
into that as well.
Now wait,
So.
so it emulates a modem. What does it
Mhm.
emulate it to? So like I know there's a lot of like I have a gadget I bought probably like 7 or 8 years ago, but it was called the Wi-Fi 232,
Yeah.
which basically
Yes.
takes a like a Hayes compatible modem and it wraps
Yeah.
it around Telnet, right? It just
Mhm.
pretends to be a modem, but it's just straight to Telnet. Is this the
And
same sort of thing?
ironically, that's where this whole project started, and that goes into the history. The history of where we jumped from that to what we're doing now is kind of bizarre. But basically, yeah. So for the Atari 8-bit, we not only had to emulate the RS-232 part of the modem, we also implemented the RS-232 interface that the Atari plugs into to do it. So we combined those two into a single unit, which eliminated that whole
That's
mess.
kind of nice.
But then it was like, okay, fine. We're doing disk, we're doing printer, we're doing modem. Okay, great. What would a network adapter actually look like for these machines? And I sat down and I thought, okay, taking from previous experience from working in the big iron world, and I'm talking mainframes and whatnot, you have these concepts of I/O processors, these self-contained computers in their own right, whose whole purpose in life is to take and translate something to something else on the fly so that
Yeah.
the mainframe can process it. Now, in the case of the network adapter, what we did was we wrote a whole bunch of protocol adapters for every protocol under the sun that you could think of, everything from TCP, UDP, FTP, HTTP, HTTPS, SSH. You'll notice I'm throwing in some some cryptographic forms in there too, but SMB, NFS, all of these different protocol adapters, and we put them on the firmware, and we made it to where this FujiNet is doing all the heavy lifting, talking to the internet out at large. And then on top of that, we wrapped in the ability to process structured documents coming in. So we added an XML parser. So data coming in from an HTTPS connection.
So the XML parser is on the device
is
itself?
on the
So you
device
don't have
itself.
to use up your
Yes,
limited
yes, you
CPU
don't
on
have
an
to use
8-bit
up
machine to
limited
do it.
memory. Yes, that was one of the problems that we really identified with these 8-bit network adapters was everybody was so obsessed with, okay, how do you add a network adapter to an 8-bit machine? Okay, take an Ethernet chip, an 8-bit Ethernet chip, and then put it on the bus. Okay, you're done. No, you're not. Because now you got to write a TCP stack. And for
Those
those of
machines,
us
that's just too heavy
who
for those machines.
it's way too heavy for
Yeah.
those machines. You wind up using most of your memory just to implement your TCP stack.
So you've essentially created a device that offloads all of
Yes,
those memory and CPU intensive networking tasks
correct,
to the device itself.
correct. You have a device that is ironically many hundreds of times more powerful than the machine's connected to.
So wait. So hold on a second though. Let's back up a second because I need clarification, and I think
Of
the
course,
listeners do too.
of course.
So you said SSH.
Yes,
Okay. So
SSH into your Linux box.
so through a FujiNet device, I could plug it into an Apple friggin' 2 and SSH into my Linux server.
Correct.
Eh, really? Like
Correct.
so I could do my work from an
Yes,
Apple 2. Like
correct.
I could administer my Linux servers from an
Correct.
Apple 2 with this.
Yes, and the Apple II, and you mentioned the Apple II specifically. The Apple, well, we have a VT100 terminal written for the Apple II, so there's your terminal emulator. So there, yeah, it works.
So you have a VT, you have a VT terminal, and I can use it to SSH into.
Yes, yes, all of the above.
I know, but this is mind blowing. I think to a lot of people because this is awesome. Like, so okay, but how fast is the connection? So I'm trying to think. I'm trying to remember how fast the serial buses on like an Apple II and like a Tandy Coco were. I mean,
The
what
speed of
like?
your bus connection to the FujiNet will vary wildly
Yeah, I was gonna
because
say.
because okay, I'll give you some examples. The Atari 8-bit normally runs at 19200 baud. Okay,
Well, that's pretty
the
decent,
yeah, that's decent.
usable.
And the AtomNet, the AtomNet peripheral bus runs at 62.5 kilobits per second. The Apple II floppy disk controller, well, that runs at 250 kilobits per second. So it goes all across the board here.
Okay.
And that's serial. We haven't even talked about the fact that we're working on a generic 8-bit bus interface as well, which will take us to everything with a card edge. So
Really?
there is that.
Okay,
Yeah.
okay. So now this is very very cool.
Yes.
So you can use this to communicate. In theory, if you develop it with just about anything online you want.
I'm loving watching your head explode here. This is great.
Obviously, we can use it for file store. So let's say we connect it to an Apple II using the floppy interface.
Yes.
And okay, now I kind of get it now because then you have faster speeds. Was there
And
another reason for that? Like
well, for
why would you could connect a modem to an Apple II? Why would
okay,
you
okay,
connect
okay,
it to a
okay.
floppy disk? And that's
So
insane. What are you, insane? I literally I can see Waz's head exploding. Like, this doesn't make
yes,
sense to me.
yes. Well, if you think about I'll answer it like this. We've decided for each machine that we are going to find the best possible way to integrate into the underlying operating system as
Okay.
best as we possibly could. Now, for the Apple II is basically, we had a situation where it was like, okay, we want to support Apple II, the slotted Apple IIs, but
Okay.
we also wanted to take and support the Apple IIc, the Apple II GS, those machines that might not know.
Oh.
So it was like, well, we've got this high-speed port, but here's the the thing that a lot of people that aren't constantly bathed in Apple II all the time don't realize is that Apple developed this whole standard called SmartPort. And SmartPort basically
Yeah.
took the Disk2 controller design and generalized the hell out of it, to the point where Apple actually added a support for character devices running over the SmartPort. This is ironic because
Did they
Apple
really?
never made, yes, Apple never made any character
I was
devices to
gonna say
use this thing.
I don't
We are
remember
the
any of
first
that.
we are the first device to actually use the functionality that they just kind of threw in there as an afterthought.
Really?
Yes.
Okay. All right. All right.
Um,
Now, okay. Okay.
So, and that's a common through line with what we've been doing. I'll give you another example of that. When Joe DeCure and his systems development team at Atari were developing the SIO interface, they not only had that high-speed serial interface that they did, but they also added two interrupt pins on the connector that go directly to the PIA chips on the computer. Well, they put them in. The
What?
operating system guys put in vectors so that you could use them, but no peripherals actually use them until we actually use them.
So you,
What do we use them for? Well, the network adapter uses them to indicate whenever there's network traffic. So we're not constantly having to poll the device. Do
oh,
you have any
that's
traffic? Do you have any
sweet.
traffic? Do you have any traffic? So that made the usage of the
You made a
interface
little
that much more efficient.
event-driven thing there. That's fantastic.
Yes, yes.
You guys
And
are
we did the same
blazing
thing.
trails.
Yes, ironically, we did the same thing for the Commodore implementation. The Commodore implementation has a service request line, which most devices never use. Well, it's there, so we just hooked in and used it, and that makes transmitting over the IEC bus, which is not the fastest thing in the world, actually usable.
What on earth? Okay. All right. All right. All right. Let's back up for a second. Let's back up for a second here.
Multiple
Um,
platforms. Yeah, I know.
so, okay. All right. So it can emulate the FujiNet adapter, the software on it can emulate a modem, right?
Yes.
So now if you plug it into, let's say, an Apple II over the floppy disk interface and your FujiNet
Mhm.
adapter emulates a modem, do you need to use software only developed for the FujiNet device, or can you use software that's built to use like a standard Apple II modem?
That's for right now, you have to use software that's specific for the
I
FujiNet because
assumed as
we're
much
yes,
because yeah.
we're forging things that hadn't been done before. There have been, experiments to try and bridge forward, and we'll continue to work on those. But for now, yeah, we have to take and use software that's specific for the FujiNet.
That's
The good news, the good news is because you've got this offloaded piece of hardware that's doing all the heavy lifting and everything, programming for it's actually pretty darn easy. So, I mean, we've written there for the Atari. One of the constraints that we did for the Atari was, well, we need to be. I want to be able to use this from Atari Basic. I wrote a Mastodon client in Atari Basic. Another guy wrote an IRC client in Basic just to do it. I mean, it's just it made it possible. And that's another aspect of this whole project is, well, whatever programming language you want to use, you just use it, because what we're doing is we're hooking in and you're doing operating system calls most of the time. So
that's
yeah,
cool. So yeah, you've got your whole TCP stack on
yes,
the device
yes,
itself.
on the device, completely offloaded. And to finish the thought, there was a thought that that got started because we can take and parse XML, because we can parse JSON. You can take these multi-megabyte JSON documents that come in from these web APIs and say, I want to query for this, and this, and this. Okay, send it down the line, and the computer can take and read it at its leisure and process it, do whatever it wants to do with it, and not have to worry about all the heavy lifting that comes with having to do a modern endpoint. So you combine the XML parsing, the JSON parsing, the fact that we can do TLS, the fact that we can do SSL, and all of that, and it means that these devices can talk to the modern internet, which is
That's so
something that the
awesome.
retro computing space hasn't had.
That's really awesome. Okay. So, I assume since you're supporting an increasing number of platforms, I saw that you guys are kind of working on DOS right now. I was reading one of your
Yes.
blog posts, and you had some video up of getting it working in DOS, which I, I'm a DOS lover. I love DOS. I can't help it. I love DOS. And so I assume since the device itself is handling all this, that porting software, the API calls, I assume, to the FujiNet are essentially the same per platform. I mean, do they change radically
They
per
are
device?
okay. So I'll answer the question in two parts. They are they're because our intent is to integrate as well into each target platform as it can possibly be. Uh, Even we have a core set of devices,
Okay.
and we have that take and connect up to a bus, which indicates how we're supposed to kind of communicate with each target machine. And so the answer is that to the first part of that question is while they are similar between platforms, they're not always exactly the same, and
Okay.
there are integration reasons for that. But on the other side of it, because that's been the case, and because we're focusing on integration like that, and because a whole bunch of us just happen to love writing in C all the damn time, um,
You crazy rebels.
yeah.
That doesn't
Oh,
sound
dude.
memory safe to me. All right. So no, continue. I
Uh,
don't mean to
so
derail
Fisher,
you here.
so one of our developers, Mark Fisher, sat down and went, okay, we'll write a standard C library for talking back and forth between FujiNet and make that a consistent point between
Ho,
platforms.
ho, 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 ho,
So
ho, ho,
that's one way
ho.
we've handled that issue.
Oh, Thomas, this sounds okay. On the device itself, I've got questions,
Okay.
man. On the
Okay.
device itself, how much memory does it have on the FujiNet device? Like how big of an XML document can we handle here? Like what's
Okay.
realistic?
So on the reference platform that we have, it's based on the ESP32, on the
Okay,
W Rover variant of the ESP32. And this particular variant has the memories in two segments. There's the high-speed memory that's 320 kilobytes. It's
okay.
inside all the DMA and everything has to happen within that. But there's also a PS RAM that's connected, and serial RAM that's connected that gives us approximately 8 megabytes of PS RAM that we can
Oh,
deal with.
okay,
Now we're using 4 megabytes of that. We haven't flipped on the bank switch bit to get to the other 4 megabytes. We haven't needed it yet.
okay.
So uh, so the other aspect of this is the flash. All of our FujiNet units have the full 16 megabytes complement of flash that we specify as part of our reference platform.
Okay.
And because we don't do over-the-air updates immediately cut your available flash space in half. We really wanted that space so we could expand. We're using approximately
Sorry about that. My OBS
storage.
screen recorder just had a giant brain fart malfunction and it just gave up life. All right. So we were talking about having that extra bank of RAM and the flash storage.
Mhm.
So
Yeah.
okay, so you can expand the storage of the FujiNet,
Yes.
right? You can stick in the thing.
Yes.
Okay, so if you can stick in like a micro SD card or whatever, right?
Yeah.
So I remember I had on that old Wi-Fi 232 I talked about. One of the neat things that I had with that was I could stick in a micro SD card, and from whatever machine I was on, I could essentially FTP essentially into the Wi-Fi 232 storage and use it to transfer files to and from all of my machines that were had a 232 serial port.
Yeah.
So what how do you access the files on the flash storage from the host 8-bit computer using the FujiNet?
Well, there are from the host computer itself. There's a couple of ways you can do that.
Okay.
So when you boot up a FujiNet, in fact, most of them, it will automatically take over and say, "I'm a disk drive, and I'm going to take and load my configuration program."
Okay.
Now, first thing it does is it goes, if you've never set it up before, it says, okay, what's your Wi-Fi network? Pick your Wi-Fi network, set your password. Okay, now you're on the network. And at this particular point in time, you have a screen that basically gives you a list of hosts that you can connect to. Those are your host slots. One of your host slots is your SD card. So you
Oh.
so you can take and put stuff on your SD card and select it there. Okay, select a disk image, mount it as drive one, boot. The other part of it too is that that particular SD card storage is also accessible from the network card. We have what we call it the N device because Atari devices all had a letter D for disk, etc.
Yeah.
So we added a whole new device called N for networking. So in SD:// and that gives you access to the local file storage there. Now, from the rest of the network, there's an additional wildcard here so that you can access the SD card storage from WebDave. It takes and does an MDNS broadcast, so you can say, oh, here's my FujiNet over here. I can take and drag and drop my files in across
Wait, so
WebDave.
if you've got two FujiNet devices
Mm-hmm.
on your local network online,
Yeah.
and you can see each other, you can move files. So if I've got an Apple II over here and I don't know, a Commodore over there, I can move files between them.
Yes.
That's super
Either through
cool.
either through the web Dave or through one of the utilities like the network shell or
So
whatnot.
this is
Just take
like
and bounce stuff across. Yeah.
this is like you guys have gone and created like an 8-bit version of, like, I don't know, Samba and Apple Talk, except just for 8-bit machines.
Well, and for that particular, what we wound up using, this was very early on, and this will go into a little bit of the history of this, just a touch.
Okay, lay it on me, man.
So we started the project in the summer of 2019.
Okay.
I was working on another project which was bringing the Plato system to retro computing users called Errata Online.
I
And
saw that, and I want to talk to you about
Plato is
this
a
at the end because I'm
that's
a
a
Play-Doh nut.
whole yeah, I'm steeped in Plato history,
We'll
and
talk about that
I
shortly.
run I
Yes,
run yeah
I
I run my own Plato instance.
I
Okay, first
saw
of all.
that. I saw
Okay.
that, and I've been resisting asking you about
All
that. Let's
right.
focus on
Okay.
FujiNet for a moment.
So I was looking for a connectivity solution for an Atari 8-bit machine for Atari 8-bit machines and other machines. And I bump into Joe Honnold, aka Moswald, who had been building this ESP8266 based modem. But the difference that he was doing that nobody else was doing was he was taking all of the GPIO pins on the ESP8266 and assigning them to pins on the Atari peripheral connector. So he was exposing them out, and I'm going, okay, let's use this. And so he and I start collaborating back and forth and getting the modem functionality working. So at first, this thing is just another one of these modems. We weren't thinking, and I had the brainwave one day, and I'm going, Moz, is the command pin hooked up? He said, yeah, of course. Huh. Wonder if I could get this thing to act like an Atari disk drive. 2 weeks later, yeah. Okay, we get this thing booting sectors. And I'm going, huh, okay, let's see if we can boot something across the internet. Okay, so I'm looking for a protocol, and I remember from my time contributing to the SpectraNet project, which is an Ethernet adapter for the ZX Spectrum.
Yep.
They had a protocol called TNFS, and I wasn't sure exactly how much processing power these 8266 devices actually had. So I was looking for something that was really simple.
Yeah.
So I went and I looked at TNFS and went, oh, this is nice and simple. So we took and adapted it and built a whole client library and whatnot in, and made it so that this thing would boot disk sectors off of the internet. And the first thing that we got successfully running was a copy of Jumpman booted from a DigitalOcean droplet about 2,000 miles away, and it worked. And it was like one of those holy shit moments. And it's like, and it just kind of snowballed from there. We wound up making.
So you can net boot an Atari 8-bit machine.
Yes, yeah. You don't need. That's the thing.
That's
You don't
so
need
ridiculously stupid. I love it.
Yes, yes. It was the original stupid pet trick. I'm telling you.
But that's awesome.
Yes.
Oh,
We basically, over the next, we did 40 of these different individual test programs that we all built, and for all these bits and pieces of functionality that we wanted to be able to try and implement.
Yeah.
And soon after, we started seeing people kind of float in, people that I knew and people that Moswald knew and whatnot, just kind of float into the project and start contributing things. I mean, we had Jeff Pietmeyer come in. I mean, that's another thing. The people that comprise this project come from the craziest walks of life. I mean, Moswald works in a steel forge. Jeff Pietmeyer, who wrote the printer emulation and brought us into Platform IO, he's a microwave systems applications engineer at the Goddard Space Center. You know, real life steely-eyed
Like
missile
you
man.
do. Yeah.
Yeah, and just random people. I mean, and so he implemented the printer emulation and brought us in and started building the first bits of the software architecture that we use today. And as one does, essentially, as we started building this thing, we were sending out prototypes and whatnot for people to use and test. And one of the people that we sent out to was one of the designers of the 400, 800 Atari 800 machines. That was Joe DeCure.
Yeah.
And
Awesome.
I've known Joe for almost 15 years at this point. And he was like, you guys should really start thinking about branching off onto other platforms and making architectural decisions to branch off onto other platforms. Okay. So we
Yes,
started
he was
breaking
right
things
about
up.
that.
Yeah.
Yeah. And
And
all the love in the world for 8-bit Ataris, but that was never my jam. You know what I mean? Like, I
it
love
just,
them, but I mean, come
I,
on.
I know. Oh, I'm in an unusual situation because of my family situation, and I grew up in a very affluent family. When you ask what machines I grew up with, my answer is yes.
I
I,
get
I,
it.
I
I
I
get
had
it.
access to them all, large and small. We had, PDP 1145 in the garage that could run Unix or Ristus or RT11. I
That is
mean,
a sexy garage right there.
I
That's what
mean,
you
dear
do.
God,
That's what okay,
I,
okay.
I
Oh,
yeah, just
okay. So on the FujiNet, so what hardware platforms does it currently support in a way that you feel is like, yeah, this is
production.
usable?
Okay, the current production-ready platforms that we support right now.
Yeah.
If you look on the FujiNet Flasher, these are the ones that are listed: the Atari 8-bit,
Okay.
the
And
Apple
is that
II.
all the Atari 8 bits?
Yes,
Okay.
yes, they all use the same peripheral connector.
Okay.
Even the XE game system, it works on that too. I have
Oh.
one over here.
Oh, that's awesome.
Yeah,
Okay. Okay.
yeah.
Continue.
All right. So it works on the Atari 8-bit. It works on the Coleco Atom. That was the second platform that we went to. Because why not? I
I
just happened to be.
I
Yeah.
find that funny. We need an additional platform. Well, definitely the Coleco Atom because so
Yes.
many.
Oh, that one was interesting to get up. And then okay,
Okay. What else? What else?
not long after that, so now Atom, Apple II.
Nice.
Apple II plugs into the floppy disk port,
And is that
and
that's the two C
yes,
the whole two
two
line?
C. For any other Apple II, you basically need to have the appropriate interface. So you need some sort of smart port interface.
Now,
There's about a
here's a
million different ways
question.
to do that.
Does it function at all on like the Apple II clones, like the Franklins and whatnot, or is that an unknown?
As far as we know, yes.
I mean, assuming that they implement all the
Yes.
things correctly.
It's yes. Yeah. As far as we know, yes. We could always use more testing.
Okay.
The so and then finally, the most recent production bring up that we did was for the TRS-80 color computer,
That's cool.
and that
Oh,
and
the
then that and
Coco
that one
needs
was
this.
and the reason we were able to get the Coco literally from development to production so quickly was because, again, this is a case of integration. This is a systems problem. So you always try to look and find the way that makes sense for each target machine. Well, thankfully, the TRS-80 color computer already had this infrastructure in place called DriveWire. It's existed for 25 years at this point. And it's basically just a tether going off to a PC running DriveWire software. It plugs into the serial port
Huh.
on your TRS-80 color computer. Well, no problem. Let's just make that autonomous. So we designed a cartridge that has the DriveWire ROM in it that makes it look like a DriveWire controller. So that plugs in, and there's a little pigtail that goes to the serial port. and it makes a completely self-contained drive wire
Oh, that's cool.
installation.
So on the Coco, it uses both the serial port and the cartridge slot.
Yes.
Okay.
We're trying to take, and that one of the reasons that we have our generic bus interface is we want to take and collapse that, so we don't need the octopus anymore.
Okay.
So we don't need the extra. Yeah.
Okay. Got it. Got it.
So, so yeah, so those are the ones that we support. The ones that we have production. That's Atari, that's Apple II, that's Atom, and that's Coco.
Awesome.
And so we have a number of other platforms that are in varying stages of bring up.
All right,
And
I
we're
want to
just
hear about these. So, okay, what's
yeah.
what's the next one? What's the next one that sounds like the
the next
most
the next one
plausible?
that is extremely close is the Commodore bring up.
Okay, what models are we talking about here?
Anything with an IEC port. So that means when I say IEC, I mean the disk drive port.
Yeah,
Again,
yeah.
the disk drive / printer port. So that's think VIC 20, think Commodore 64, Commodore 128, Commodore Plus 4, Commodore 16, those machines. And
So
yes, it works on all of those. I've written software to take and test it on all of those. It
so
works.
and
I have
you
a weather display for the VIC 20.
and you're saying that that is realistic, that could be
Yes.
production ready sometime
Yes,
soon.
we are
Sometime.
we are very close. We are very close with that. Basically, what we're doing right
What does
now
very
is
close mean? Don't. I'm a dev. I know what very close can mean a
very
lot of things.
close. Very close means that the protocol works. We are working out timing issues.
Okay, fair enough.
That we are working. That's the nature of what we're literally just having to work out timing issues and getting that first revision out, and then as we start implementing variations in the fast loader protocols, implementing Epic's fast load and
Okay.
all of that will come in. We already have provisions for all of that. It's just debugging all of that.
So, and when that happens, you'll be able to get a Commodore 64 online on the same network,
Yeah.
talking with an
And
Apple II, and
yes, and
an Atom.
yes, yes,
Okay.
and yes.
What comes next? What comes next? 'Cause I saw DOS on there. So how
So
far along is the DOS side of things? Got to give it to me
the
straight.
DOS, well, the DOS, the protocol side of the DOS, the protocol side for the DOS version is kind of interesting because we're doing this in two different ways. The first version is implemented over RS-32.
Fair.
Why not?
Why
I'll
not?
go ahead and
Yeah.
just to get something running. And for that to work, what I basically did was I took the Atari SIO protocol, cut and pasted it into
Good.
RS-232,
Good.
mapping the pins. So it uses the same protocol. All of that's debugged and it works. What's the challenge on the PC side is coming up with a this is going to sound funny, a BIOS interface for it. Because what we want to do is you have on for those that are not familiar with MS-DOS style programming, you can of course deal with the hardware directly.
Yeah.
And that works if that doesn't ever change. Okay, fine.
Yeah.
But if we're going to be making a version that uses the RS-232, and then when we get our generic bus interface working, we'll make one that runs over ISA. We need a standardized way to talk to both of these, regardless of what may be on the other end. So the solution to that is to take a BIOS interrupt, say interrupt F5 or something,
Okay.
and write a BIOS interface to it to say, okay, do this, send this command,
Yeah.
wait for this reply, that sort of thing. And implement that as a BIOS extension. And then on top of that, write an MS-DOS device driver that hooks into int13.
So you need your old int13 TSR that does all that stuff. Okay.
Yes, all of the above. So we can integrate in and be able to boot disks over the internet, or be able to take and do all the things that we've expected from FujiNet from any PC application.
Now, how viable? So anyone who's done a lot of work on the DOS side of things knows that those you can get a TSR up and running, but one of the big problems is how do you make sure you keep it small enough so most DOS software still actually runs when the TSR is up and going. Do you guys think you can get the functionality of working with the FujiNet small enough that that's not too big of a problem? I mean, that's a challenge.
It's an interesting challenge, but I think we can do it. Really, I'm toying with two different approaches to basically implementing this. But they basically we either put all the smarts in the TSR for each command we're going to do, or the absolute minimum that we're going to do. So send command, receive
Oh, I
response.
gotcha. Yeah.
And then you just send the commands. You say, I want to mount this device to this slot using send command, and I'll get the response back and that sort of thing.
Okay.
So all of this is doable. The challenge that I'm honestly having on the MS DOS side of things is for the RS-232 version is writing a set of serial routines that I can either embed into a BIOS service or as part of a device driver. Because the moment you start doing things like interrupt-driven serial port transmission, you get into some black holes really quickly,
Sure.
and things and try to debug interrupt-driven serial port routines using Turbo Debugger. It's yeah,
No,
I'm
no,
using Bold
no. I
C.
want you. I want you to do this, and then I want to play with it. I don't actually want to do this.
I,
No.
that's the funny thing. I've written code for so many of these platforms. I mean, I'm close to about four or five, four, 40 or 50 platforms that I've written code for over the
Yeah.
last forever. And it's weird because I have things that I love about each and every platform, and I have PTSD for every single platform I've ever written
Well,
software
you
for.
can't. If you're a dev, like that's always been one of my thing. Like every time I've ever hired a good dev, one of my first questions is, hey, tell me what your favorite programming language is, and they tell me their favorite programming language, and then I say, okay, great, tell me why it's the worst programming language ever, and it's the cause of all the pain in your life. And if they can't tell me like a nonstop list of everything they
They
hate
don't
about it,
have the
they don't
experience.
actually know it. Yeah, yeah.
Yeah.
Um,
So I mean,
Okay. Okay. So
so
we got. I mean, you guys are clearly tackling a lot. Are there any other? I have to ask. Are there any other platforms that you guys are
tons.
toying with?
Okay. All right. So tons. Here, let me just do a little. I'm going to
Tons?
take
What do you mean
tons.
tons?
No. Here. I will take and just read off the list from our platform planning. Okay. Let's see. Acorn and BBC Micro.
Well, that would be fun.
Uh,
That would be fun.
Apple 68K, and by that we literally mean Mac 128K, Mac 512K, Mac Plus. These small Macs. Okay,
The
that's
good ones.
functioning.
Yeah.
Yeah, but that's functioning. Atari
Whoa.
2600.
Back up. You can't drop that bombshell on me. Wait a minute. That's
What?
functioning.
What?
Wait. Are you
Yeah,
saying that someone has actually gotten that to work on the 68 those old 68K
yeah,
Macs?
yes.
What is it? What does it connect over? Like, is it just the standard RS-232 port? You guys going ADB weird? Like, what are you doing here?
Are you ready to laugh?
Yeah, I'm ready to laugh.
Hey, take a guess. Just take a guess.
You're not? Are you doing it over like ADB, Apple Talk? What?
Nope, nope.
What?
Floppy port.
What do you mean floppy port?
I mean, we're using the IWM just like we're using in the Apple II.
You are
The
not.
the Macs have an IWM too. We're doing it over the floppy port because why not? We were
Huh?
able to. There's a strange multiplier. Yeah, there's a strange multiplier effect that happens with each platform that we successfully prove that we can do. That gives us a vector onto 10 more. Okay.
Okay.
So
I should not disrupt. You should continue, but you're on the floppy ports on a Mac. Okay. All right. Awesome. And we're back. OBS had another brain fart. Thank you, developers of OBS project. I shouldn't dog on them because it's great, but
the fact that it works well is a miracle.
okay. All right. So they plug it. So you're plugging floppy port on a Mac. All right. Now
Yeah.
what's the next
Okay.
one? What's the next one?
All right. All right. And I'm going to say this right here with a nice long pause so we can really get this sunk in here.
Okay.
Atari 2600. Via the cartridge port. Yes.
Well, a 2600.
Yes.
A VCS.
A VCS. With 128 bytes of RAM. 4K of ROM address space. Yes.
Okay. You're gonna have to talk to me a little bit more about this one because say what
Okay.
now? So okay.
Yeah,
So
well,
all right, all
that's
right.
the other side. That's the other side of this equation. It's not just retro computing systems that we want to target. We want to target retro gaming systems as well.
You're
And
messing with
so,
me right now. A 26 friggin' hundred.
yes,
So in
yes,
theory, you could over Wi-Fi share a file between an Atari 2600. I mean, a game thing. You can move
you
it
can
between that and your Commodore 64. In
already
theory,
been there, already been there, done that.
you've been there, done
It's
that.
functional. I mean, this is
That is like
it's
the
functional.
ultimate retro like gamer show off. Oh yeah, I've done that before. Of course I share my wireless files between Atari 2600. Come on, dude.
Okay. So here's the deal. With the retro gaming systems, the focus is slightly different.
Sure.
Of course, the goal here, first and foremost, you can load any game that you want to off of the internet
That's a
directly.
great one. Yeah, that's great.
Okay, so you have access to this instant library here. And on the other side of it, we are opening up a whole area of, because you've got this network adapter with all these protocol adapters and things, and you can parse JSON and parse XML and things. That means you can do networked
Oh
games.
man, an Atari
And
2600
yes,
multiplayer combat sounds
yeah,
awesome.
and so we did the initial proof of concept to show that we did a game of 5 card stud against an Atari 2600, against an Atari 8-bit, and against an Apple II, a TRS-80 color computer, all playing together at the same time. Do you realize the implications of that? I
That's
mean,
awesome.
so there's so the Atari 2600 version bootstraps off of the wonderful work that the Plus Cart community has done, and the Plus Cart people have basically they built their own little extra special cart that's based off of an STM32 that adds in an ESP3266 for the wireless communication and whatnot, and they built their own API, and this kind of reaches to the rather unique community, greater community that we're building here. It's not just us. We've reached out to the PlusCart community for the Atari 2600. The Commodore version of FujiNet builds off of the wonderful work that the Meatloaf project has done. And so we're all working together as kind of a loose confederation, passing
Yeah,
code, passing ideas and things back and forth together to build a very loose confederation of platforms.
this is amazing.
So Atari 2600. Okay. The Let's see, RC 2014. If you've seen the RC 2014 Z80 based machines, there's a guy working on that.
Okay.
Uh,
Why not?
so yeah, why not? The ZX Spectrum, of course. There's a guy he's
Of
the guy that's
course.
doing the ZX Spectrum work is the guy who's actually heading up our generic bus design,
There's
and so it's
always
being.
somebody who just loves horrible color palettes. And they
I'm
just
telling you.
and they just have to make something for the ZX Spectrum.
Oh, dude,
I don't
I
mean to
have a
dog on the ZX Spectrum, but that color palette is
I
right up there with the old CGA color palette as just
oh
like
yeah,
these just need
yep.
to die.
Yes. So I have a ZX Spectrum laptop, an Omni 128HQ that I set aside for this purpose. But yes, the ZX Spectrum, Amstrad
That
CPC.
said, a ZX Spectrum laptop does sound kind of awesome.
Yes, it is really neat. Uh,
Okay, continue,
the
continue.
Amstrad CPC.
Nice.
Uh, we did. Oh, sorry. I do have to. I forgot about a platform. There's another platform that we did that we did a proof of concept for. We showed that it worked.
Yeah.
It's just in the freeze until we can get more people to work on it. The Atari Lynx. We actually successfully showed that we could tunnel comm links over UDP from one links to another and
Whoa.
play games like Rampart and Checkered Flag and whatnot over an internet connection, as
That's
well as being able to load
cool.
games and stuff like that. So we did one for the Atari Lynx. Uh, I have a Bally Astrocade here waiting for when it gets its turn.
Nice.
There's a guy working on a version for the Heathkit H8 and H89
An
machines.
old Heath kit.
Yes.
Dang.
Um, MSX, we want to do it for MSX machines. We've been from time to time, the collaboration needs to be restarted, but with the Nabu people,
Of
with the Nabu
course. Yeah.
PC people.
Yep.
Um, the PC 8801, the PC8, the NEC PC 88. I want to do a version for the S100 machines. So put one of these in an Altair or an MSI. Um, I have um, I have
Oh.
I have a prototype cartridge for the Intellivision right here that I'm about to put on the bench.
And in
Um,
television, that's ridiculous.
yes, and it just keeps going. I'm not being hyperbolic when I say, "Hey, this is the hill." That old adage, "This is the hill I die on." Well, this is the hill I die on. So this is
It's awesome.
we're going to be spending the rest of my life basically coordinating and bringing this to as many different retro computing platforms as
God bless
we
you,
possibly
man.
can.
Okay.
So,
All right. Now, okay. So,
and we have the expertise to do it.
what's production like? So, I mean, the software is one thing. We can all grab the software, but the hardware, we got to get hardware from somewhere. Like what hardware is actually realistically available? Like people can go buy it at this point.
At this point, production hardware, if you go to our, I find it funny that I haven't plugged the website
Yeah.
yet.
Plug the website, please.
Yeah.
Plug the
The
website.
website, you can go to FujiNet.online. And on FujiNet.online, there is a wonderful button that literally says, "Get a FujiNet." And the way that we function, this is kind of funny. Um, this is purely a passion project, and there uh, I don't get my income from this at all. My income comes from my day job. Okay,
Right.
so I don't have to worry about that. So I've completely divorced myself from any of that. When somebody makes a FujiNet, when a vendor wants to make a FujiNet, we don't ask for any licensing. We don't ask for any sort of compensation. We try to work with them so that they can make these devices effectively.
Nice.
But back to my original point, on the website, get a FujiNet list of vendors. And if you want to be on that list, cool. Take and come in and start talking to you. We'll put you on the website so you can take and grab the FujiNet. So right now we're looking at there's about 5 or 6 vendors right now that are active that are producing all of these. And the whole idea and the intent is to have vendors that know their communities
Yeah.
and can sell to their communities. And it's very much a hands-off situation. We don't make them; we just design them.
And then you and
Oswald,
yeah, and then you hand it off, and here's the schematics.
yes,
Here's what needs to be built.
here's the schematics. Here's the bomb. Here are the Gerbers. Go take and make it. Moswald will make some to cover his development costs. And so sometimes you'll see you can buy them directly from him, but there's no uh, there's no bottleneck there.
Awesome.
And to further the point, this is rather interesting. This has been going on for 5 years now, and in that 5 years, we've all as a collective people gone through some stuff, man. I mean, the COVID pandemic and the chip shortage and everything
Yeah.
else. So it's taught us a whole bunch of things. And one of the things that it has taught us is that we have to make sure that what we do is reasonably portable enough so that if for some reason the supply of ESP32s disappears tomorrow, we can take and lift up and go on to another platform and not lose features.
That's awesome. That's
And
awesome.
so, to that end, what we actually did to really drive that point across, not only can you have the FujiNet devices as a physical device itself, you can have it running as a piece of software on a development PC, for example. We have a thing which we call FujiNet PC, which is the FujiNet firmware running as a POSIX or Win32 application.
Interesting. So
And
then you could
that
tie it into like an emulator or something like that?
Yes, correct. That's exactly what we've done. And we've taken that to its absolute extreme. We even have a virtual machine that we've put together that you can load into KVM or you can load it into VirtualBox or whatever. and have a whole development environment so that you can start up a copy of Altera that's already pre-configured with FujiNet integration, or start up a copy of AppleWin that has the FujiNet integration, or a copy of MAME that hooks into the Cocoa version, and you can develop your software, your FujiNet software, using the wonderful debugging facilities
Yeah.
present in most modern
Right.
emulators.
So you don't have to be developing on the hardware. That's brilliant.
As much as I love developing on the hardware from time to time, it's nice to be able to say, okay, breakpoint, bang.
Yeah, and have several windows open for copying and
Yes,
pasting. It's a life changer. Yeah.
yes, yes,
Oh, that is brilliant. So people can grab that from FujiNet.online already. So they, if they
yes,
want to
yes.
play around
That's
with it
all. If
in
you
an
want to play
emulator, they
around with it,
can.
yeah, you don't even have to have the device. You can literally just run the emulators and see what using a FujiNet is like before you ever
Before you
actually
go and
buy.
buy one.
Yes, yes. That,
Brilliant.
among other things, there's a whole bunch of reasons. But the funny thing is through all of that, it proved to us that we could take our code base and move it onto any embedded platform. So that if we need to do that at a moment's notice, we can.
I love this. I love not just bringing the old machines to the modern internet. That's great. But in a way, it sort of is like an opportunity to almost reimagine
What
what
it could be
the
like.
internet could be. Yeah, like there was we've had so many discussions in the Lunduke Journal world over the years of how great the internet is and how much it absolutely destroys everything. You know, there's so many issues, and a lot of us talk about doing things like, well, maybe at home we don't use the internet so much on our phones. We sit down at stations and have computers set up and use it more like we did in like the 1990s, you know? And what does that do to our life? And thinking about sitting down at a 68K Mac and an Apple II and an old Commodore 64 with my kids set up, able to have a lot of the benefits of the
Yeah,
internet connection, but without all of the sketchy stuff that you don't want your kids getting access to.
yeah.
And I love that. I love
Hmm.
that. It's like if I were to transport us back in time to the 1980s as kids dreaming about what we could have done with our Commodore
Yes,
64s.
yes,
But in our heads, computers will always be the Commodore 64s, but what could we do with them? And now I get to show that beautiful hypothetical future to my kids.
yes,
That's beautiful, man. That's
yes.
beautiful.
That's been kind of the interesting thing. It's opened up a whole this bizarre space where we can do a whole bunch of experiments that otherwise just were not available. I mean, crazy things from simple things like being able to write an IRC client in BASIC, or there is in the retro computing community, for as an example, there's what we call the 10-liner BASIC contest.
Yeah, it's a beautiful one.
Yes, and it's just the whole premise is you take and whatever you can write the whole universe, but you have to do it in 10 lines of BASIC. So one of the things that I wanted to do from the very beginning was to take and bring FujiNet into that discussion to see what sort of network things we could actually take
In 10 lines
and
of basic.
do in 10 lines of BASIC. Now, yeah, I want to say so much of some of the things that I've seen that are going to be submitted to the 10-liner basic contest yet, but I can't.
Oh, that's fun. I mean, you can
I
imagine. You
can't,
can
because the contest is
imagine
going on right now.
if you've got the Fuji off in there and able to handle TLS and XML parsing
Hmm.
and everything else,
Yeah,
you can imagine what you could do in 10 lines if that's doing all that heavy lifting. That's brilliant.
yes, yes.
That's
And,
absolutely brilliant. I love it when I mean, I love my old hardware. I love it. But I like to modify it as little as possible while still expanding it. You know what I mean? Like
Mhm.
I love it when people have like I've seen like Raspberry Pi based daughter boards that you can stick into an Amiga that give it a
Yes,
whole bunch of processing power
yes,
without having to
I,
take out the soldering gun. Like I love those sorts of things, and
yes.
this is beautiful. FujiNet's kind of one of the coolest things I've seen along those
Well,
lines.
and we're kind of at the cusp of something rather interesting that's happening, because the one piece of hardware that I haven't really mentioned here that's starting to fold its way into our designs. You've heard about the ESP32, but we're also folding in the RP2040 and the RP2350, which are part of the Raspberry Pico and Pico 2, those
Yeah,
devices, all the clones. And we're using those as our bus front ends, more right now at the least. But it opens up a whole new avenue of thinking, because now you've got these processors that have these little macro blocks that can do very fast I/O transfers back and forth. They can wiggle signal lines really, really
good
fast.
wigglers.
Yes. And so you've got devices that are using these Picos that are verging on what I would call software defined peripherals. And so you've got like the devices like the PicoGus and the PicoMem that are basically they're ISA cards that are basically using the RP2040 as the core of their functionality, providing the sound card, providing memory expansions, providing all of these different things. And as these microcontrollers migrate onto these various cards and devices, they are taking the place of complex programmable logic devices
Yeah.
and arrays, which add quite a bit to the bill of materials costs they traditionally have, because they're very low yield devices. No matter how you slice them, the economics of it will always get in the way and drive the cost of your peripheral up by $50 to $100.
Right.
So, in contrast, the RP2040 and the RP2350 and whatnot are being made in such ridiculous
Oh, they're
yield
being used everywhere. Yeah.
that you're getting these things. You're getting these things that can replace so much of the functionality of these CPLDs and FPGAs, and your bill of materials cost suddenly goes down from $25 to 50 cents in singles.
Right. Crazy.
And
That's crazy. That's
that
crazy that that's
changes
possible.
everything. That changes everything, because now you can start thinking about, well, what other functionality that can we add in
And the amount of
when we
power that are
do.
in those for that cost is nuts.
Yes, I know. I mean, and they're powerful enough by themselves before you add any co-processing on them to do some pretty heavy lifting. One of the ideas that I have, for example, that's in the back of my head. I've been putting pieces on how to do this. I have an Amiga 1000 just across from me
Of
over
course you
here.
do. Of course you do.
It's my daughter's and mine paint box. Okay, one of the videos I did, I do a whole series of videos on what using an Amiga was like in 1986, because I was there. So using
Those
it
were
as a
good
developer,
times. Those were good
all that
times.
stuff.
Yeah.
But one of the things that I want to do is we want to, of course, make an Amiga FujiNet that plugs into the Zorro slot.
I was going to ask.
Um, and but I also wanted to do some additional features, like say, for example, you take libNDI and you put it on the Pico.
Okay.
Well, NDI, for those that don't know, that's Newtek's network device interface for connecting cameras, video
Yeah,
cameras, and
yeah, yeah.
whatnot
For
over
video
a network.
toaster and the like. Yeah.
Yeah, yes. Modern implementations of video switching and whatnot. Well, why not make a freaking frame grabber that where all the heavy lifting is being done by the controllers on the Zorro card, that can take and get as its network source, instead of a composite video signal, an NDI signal. So, any like my cell phone that's running, NDI camera HX, that suddenly becomes just a frame grabber source. Crazy, weird little stuff like that.
What?
Yeah.
I can I tell you straight up, I love that idea ridiculously.
Yeah. I have another friend who would very much appreciate that idea too. So believe me, Amiga
Oh
Bill would
my
love that idea.
word! We've joked for years here about how great would it be if we stopped using all this newfangled stuff and we found a way to produce the shows that I do entirely in Video Toaster, right? With old Video Toaster effects and everything.
Yes.
We just gotta manage to get the output right and all that. I mean, it's kind of doable, and but this would take it several steps forward in that direction. Oh man. Oh
Yeah.
man. I mean, how awesome would it be to have like an Amiga 4000 sitting here with a FujiNet plugged into it and
Mhm.
whatnot, and doing shows and do
Yes.
it all like VHS, like standard NTSC resolution. Oh, wait. Oh my gosh. OBS screwed up again. It's like the 18th time. All right. That's a sign. We should bring this in home. Thomas,
Yes.
I have a lot of things that clearly I need to talk to you about.
Mm.
We need to spend some time talking about Play-Doh. We don't
Okay.
have that time today.
It's
Play-Doh,
okay.
I've done articles on the history of Play-Doh. Play-Doh is one of the most amazing and fascinating, not only early online systems, but early user interfaces. And they had so much going on there. And it was absolutely just monumentally influential. And you run sort of a modern implementation of
Oh,
a Play-Doh system.
I run an actual Play-Doh instance. It's running on a CDC 6600
That's insane.
emulator,
That's
and
insane.
yeah, I'm running an actual system. It,
Thomas Cherry Holmes, you are a crazy man, and I absolutely love it. This is what you're doing is fantastic. I'm gonna you must come back on to talk with me about Play-Doh. But
okay,
we got to cap it there.
okay,
FujiNet dot online.
yes,
Uh go check it out, everybody.
yeah,
This is just way too neat. I mean, everyone who watches the Lunduke Journal regularly knows. I mean, I've got my own little telnet BBS up and running, and this is I love this. I absolutely
I have
love
a
this.
I have an Atari 800 here with a FujiNet attached that runs its own BBS. It runs a copy of BBS Express. It's just sitting here accepting calls, so to speak. But yeah, it's able to do that too.
So
That's the other aspect of it too. I mean, not only client connections, but it can also initiate server
so
connections too.
you
So
could plug in a FujiNet to an old machine and run a telnet BBS
yeah,
on it.
yes, yes, and
That's
that's exactly
awesome.
what I'm doing here.
I love everything about that. I mean, you can only it's going to be one per node, obviously, so it's one node at
Yeah,
a time. But still, that's cool.
yes, yeah, it
Well,
works.
get a bank of FujiNets going and connect them up to it. All right. I digress.
Yeah, it works.
Thomas, thank you for talking to me about this. I honestly, I gotta be straight with you. I do not understand why this is not getting talked about more. I mean, it is not only technologically interesting, but it is doing something that I think is actually not only fun but potentially important in as a sociology experiment of how to mash together some of the best of modern technology with some of the best of old technology. And I love that people are so passionate and working about this. So hopefully more people talk about this. Hopefully no one yells at you and tries to cancel you because you came on my show. But man, great work, man.
Thank you.
FujiNet.online. Is there anything else you want to say to people before we send them off into the ether?
Come to the website. The website also has links to our Discord, which is where we primarily hang out to take and talk about these things. And I want to thank you. There are so many different things that we can do in today's world to take up our time. Therefore, I am thankful for each and every person who has decided to spend time hacking on FujiNet.
Hell yeah. Love it. With that, ladies and gentlemen, Boys and girls, nerds and nerdettes across the inner tubes, I do declare. End broadcast.